Okay, so we figured out evaluating functions given the chart and given um, the equation, but what about a graph? Well, it's actually pretty easy. It's kind of like a chart. So basically going to be given a graph and we're going to be evaluating functions. Plugging in an x value, getting a y value back. Example 1. Alright, so we have a graph here. Nothing too fancy, right? Got a hole up the top and a solid point at the bottom. It says evaluate f of 3. So the first thing we're going to do is we've already talked about the fact that the number in the parentheses is the number you're plugging in, which is your x value. So we're going to locate that x value 3 on the graph. Okay, so look at the x-axis, which is down here, right? Here's 3. Simple. There's your first step. Locate the x value. Next, we're going to draw a vertical line at the x value. Okay, so let's go ahead and do that. So at x equals 3, all I'm going to do is kind of just sketch a little vertical line here. Sweet. Next step, draw where the line intersects the graph. Okay. And so if we go back to the graph, we can see that, oops, don't want to move the vertical line, it touches right here, right? Basically, we're figuring out the y value. Now we're going to draw a horizontal line back to the f of x axis. So once we figure out where it crosses, which is right there, we're going to start at the intersection point, go back to the y-axis. And what is that y value? That y value is 2. So what does that mean? That means that f of 3 must be equal to 2. So it's more or less just figuring out a point on the graph. Okay, 3 is your x value. You're figuring out your corresponding y value, which in this case is 2. Okay, the point here is 3, 2. So if you're familiar with points, this should be a pretty easy lesson. Next example. We have a same graph, and now it says f of 2. Okay, so what is f of 2? So again, we're going to locate this x value on the graph. In this case, it's 2 instead of 3. So now we're going to hover over 2. Okay, and then now it says, and now we're going to draw a vertical line from there, and then we're going to see where it intersects the graph. So let's go ahead and just kind of do that one thing at a time. Draw a vertical line at 2. Now notice, guys and girls, it only actually crosses once, okay? It does not touch up here, it only touches here. Okay, so now we're going to take that and draw a line, horizontal line back to the y-axis, and guess what? We get 1 back. So when you're evaluating a function, you have to be careful because for holes especially, it's not touching at the hole, it's only touching here. So the actual y value is 1, and so therefore f of 2 is equal to 1. So just follow those simple steps and you'll be able to easily evaluate a function given its graph. Example 3, we have a pretty complex graph here. If you look at it long enough, you'll be able to realize it does pass the vertical line test. Nowhere does the vertical line touch twice, so this is definitely a function. Evaluate f of negative 2.5. Okay, so we're going to go at x equals negative 2.5, and we're going to locate it. So here it is, right here. Negative 2.5. And then we're just going to do this one together real quick. We're going to draw a vertical line there like we did before. Okay. Then it crosses right here, right? And then we're going to just figure out what that corresponding y value is, which again is actually going to be 1. So across here, then we draw a line back to 1. And so therefore, f of negative 2.5 equals 1. Let's look at some more advanced examples. Same graph. Now we're going to figure out what f of 1 is. Okay, f of 1. Let's locate the x value on the graph. Same steps. Okay. Well, here's x equals 1, and if we actually draw a vertical line, even though it's kind of obvious here, look, it only touches once. It does not touch up at the hole, it only touches here. Now the question is, what is that y value? The answer is it's not 1, that's the x value. That's why it's kind of important to kind of go back and see it crosses at what? Y equals 0. So therefore f of 1 in this case is going to be equal to 0. So basically, if the point's on the x-axis, then that means the y-value is going to be 0. Same graph, and now we're going to figure out f of 1.5. Again, we're doing some a little bit more advanced problems. So let's find the 1.5 on the graph, on the x-axis, which is right here. Now here's the thing. When you draw, maybe I should go back to that. When you draw a vertical line at 1.5, does it touch the graph? The answer is no, right? It doesn't touch. So there really is no horizontal line to go back to see what the y value is. So when it doesn't cross, and so the answer is pretty obvious, it's undefined. If it doesn't cross the graph at that x value, it's undefined. Example 6, we have some letters to deal with. Okay, so we have A, B, C, and D, and then L, or J, K, and L. So you can actually evaluate at letters, it's perfectly fine. Let's figure out what f of c is. Okay, so we're going to locate that x value on the graph, which is right here, right? And then we're going to draw a vertical line right there, just like we were doing before. Now, where does it touch? Okay, I'll give you a hint. It doesn't touch here because it's a hole. It doesn't touch here. It only touches there. And again, since it's a function, it can only touch once. Then we're going to, that's where it crosses the graph. Then we're going to draw a horizontal line back. And what do you get for the y value or the f value? You get k, right? So you can get a variable back when you evaluate functions. It's perfectly acceptable. Therefore, for our final example, f of c equals k. So that's evaluating functions given a graph. It makes sense that the x value is you find by looking at the x-axis, and the y value you find by going back to the y-axis. If you have any other questions, let me know.